ideal fluid in motion. Students, you ever feel why would you put your thumb over the end of a garden hose? जो आप बगीचे में पानी सींचते हैं, सिंचाई करते हैं, तो उसके जो पाइप है उसके सिरे पर आप अपना अंगूठा क्यों रखते हैं? आप अंगूठा क्यों रखते हैं? ताकि ये जो पानी है ये काफ़ी आगे तक जा सके। ये तो आप सभी को मालूम है। All of you know, whenever you take your thumb on the end of the garden hose, the water will move more distance. Why this happen? In this chapter, we will take all the answer of this. First of all, we discuss how the liquid flows. The liquid flows in two ways. The first one is the streamline flow, and the second is the turbulent flow. What is a streamline flow? This is the regular and orderly flow of a liquid. Here is the diagram. In this diagram, we have the liquid molecules which are flowing. These particles are A, B, C, D, and so on. The particle D is moving in a straight line here. The particle coming after that at this point will also follow the same path as the path followed by D. So, the path followed by A, path followed by B, path followed by C particle of the liquid will be same as the path followed by particle D. So, they are moving in a regular and orderly manner. Similarly, in other layer, the particle M will follow the path of N, of K, of L, of P. So the preceding particles and succeeding particle have same path followed in streamline motion. In this flow of motion, the liquid particles is parallel to each other. If we say the particles which are moving in a line A, B, C, D are parallel to the line M, N, K, L, P. And similarly, the other lines of the particles are parallel to each other. There are different layers here, and they are moving parallel to each other. If we consider the layer, then we will say it is laminar flow. If you consider in a single one dimension, then you will say it is a streamline flow. In this flow, the velocity of a liquid is less than a critical velocity. That velocity depends on the nature of the liquid, and that velocity is a limiting value, and that limiting value is called critical velocity. तो जो पार्टिकल इसमें सीधी लाइन में जा रहे हैं उनकी वेलोसिटी क्रिटिकल वेलोसिटी से कम होगी. In this flow, the liquid velocity is constant. It means the velocity of each particles are constant, whatever the position of the particles. The second type of flow is the turbulent flow. This is the irregular and disorderly flow of liquid. Now here, the flow of liquid is not in orderly manner. The particle A is moving like this one. The particle B is moving like this one. The particle C is moving like this one. So there is no particular framework. So the particles are flowing in irregular and disorderly manner. In this flow, the motion of liquid particle is not parallel. Here, the line followed by the particles are not parallel to each other. And in turbulent flow, the velocity of the particle which are flowing is more than the critical velocity. The velocity of particles are more than the critical velocity of a particular liquid. And the velocity of different points of the particle is different. So they are not constant. So these two types of flow of particles of liquid we discuss as a streamline flow, turbulent flow. Now, what is an ideal fluid? The steady flow. The ideal fluid will follow the steady flow, means streamline flow or laminar flow. Incompressible flow. It means the density of the liquid remains same all the time. The density of the liquid remains same all the time, and the liquid is non-viscous. It means there is no viscosity. We are assuming the fluid is ideal. And irrotational flow means they are moving in a particular path which is moving forward, not rotating. Here is the liquid. Let us consider here is the liquid inside this tube. And this liquid is flowing left to right, that is from point A to point B. Here is point A and here is point B. The liquid particles are flowing in a steady flow nature. Here is streamline, here is a streamline, here is a streamline. And here is also a same nature. They are converging. Again streamline. There is no rotation of the particle. They are moving from left to right. Now let us, we say, here is the tube of different cross-sectional area. The cross-sectional area at A is A1 and at B is the cross-sectional area A2. Now if we consider the velocity of the particles at point A is v1. The velocity of particle at A is v1. It means here is v1. The velocity is v1 here. And the velocity of the particle at other end is v2. Here it is v2. So at inlet, the particle takes a distance delta x1. The particle is take a distance delta x1 at time delta t. And the particle here at the ends, other end, take distance at delta x2 at same time. Then, if the fluid is incompressible, means the density is same everywhere. So the volume which enter here in left side at inlet per second will be equal to the volume coming out per second at point B. It means the mass flux of the liquid is same at A and at B. So, we may say the mass content at A is equal to mass content at B in time delta t. So, we are saying the mass is conserved. There is no sink here in the tube. But we know the mass is density into volume. Into volume. This volume is at A will be equal to density into volume at B. The density is rho, volume is cross-sectional area into length. Cross-sectional area is A1 here, and the length taken is delta x1. Will be equal to rho, the density is same because the liquid is incompressible, into area is A2 and length is delta x2. So volume is delta A2 delta x2. As we are saying, the mass incoming is equal to mass outgoing in time delta t. So we divide this one by delta t. In both sides. What we are getting here? Delta x1 by delta t is the velocity at inlet. So it is V1. And here it is V2. We may cancel the density part in both sides. So we are getting an equation that is A1 V1 is equal to A2 V2. This equation is called equation of continuity. The equation of continuity. The equation of continuity is based on the principle of the mass flux in both sides is conserved during the flow of liquid inside the tube. So